everyone. Good evening, good evening, good evening, good evening everyone. Are we live? Am I audible, visible? जल्दी से बता दीजिए क्या मैं लाइव आ चुकी हूँ, क्या मुझे देख पा रहे हो, सुन पा रहे हो? Are we live? Yes everyone. A very good evening to all of you. How are you all? I hope आप सब बढ़िया, एकदम मस्त और एकदम ढिंचैक. Yes. तो बच्चों, आज हम शुरुआत करने जा रहे हैं एक नई जर्नी की इस चैनल के थ्रू, राइट? So today we are going to start with a new series, that is NSEJS 2025 Chemistry Series B2A, that is Basics to Advanced, right? So anyone who wants to crack NSEJS 2025, he or she can follow this series, and I'm sure this series is going to help you to crack one of the most prestigious exam, that is Junior Science Olympiad, NSEJS, right? So in this series, we'll be having sessions in chemistry, physics, biology, where we'll be teaching you all the important topics from basics till advanced that can definitely help you to crack questions that will come in your NSEJS exam, right? Yes. So today in chemistry, this is the very first session. I am going to start with the very basic fundamental of chemistry, the atom, the atomic structure. And what is new in this series that you can see on the thumbnail, guys? The mode of communication in this series is English. So any student in India can follow this series because we are going to teach you in this series in English only, right? Yes. So 8 to 9 p.m. this series will come on alternate days on this channel, and we'll be covering all the three subjects, physics, chemistry and biology in this series. Yo, are you happy, guys? Are you excited to learn chemistry, physics and biology way beyond your school curriculum via this series, B2A series, Basics to Advanced series for NSEJS? Yes. Quickly let me know. Are you all happy? Yups. Are you all happy? We'll be studying each and every topic in detail, chapter by chapter, topic by topic in every session. Yes, guys, are you happy? Are you excited for this series? Yo, jaldi. Yeps. Let me know. So if you're happy that we launched this special series for NSEJS aspirants, anyone can learn science from the comfort of their home. Right? They can go beyond their school curriculum, explore science, learn science from the comfort of their home via this series, that is B2A series for NSEJS 2025. Good evening, everyone. Good evening, everyone. So what you can do to boost the motivation of the team, right? Just click on the like button, guys. Yes. So that we also get to know that you want this series and you appreciate that we are launching this series to teach you in detail in English. Okay, guys. So in this series today, I'm going to start with the, chapter atomic structure, or you can say structure of atom. So before starting, let me quickly introduce myself. Myself, Nidhi Parashar, master teacher chemistry, and I have been teaching students for various competitive exams, JEE, NEET, and Olympiads since 2009, right? So the testimony of results that VOS Vedantu has, that itself shows our expertise in the field of Junior Science Olympiad, NSEJS. Got it, guys? Okay, so let us start the beautiful journey of chemistry in this series. Okay, guys, so let me know, what is chemistry? What is chemistry? I'm sure you all know the chemistry is study of matter. So if I ask you, what is chemistry? Chemistry is that branch of science which study matter. What is matter? Anything which has mass, occupies space, has certain volume, that is matter, right? So what is chemistry? Chemistry is the study of matter. Anything that you can see which has mass, occupies space, that is matter, right? That is matter. And chemistry is the study of matter, right? And chemistry is the study of matter. We study the composition, the chemical properties, the behavior of matter in chemistry, right? Can any one of you tell me what everything around you which you call matter is made up of? What matter is made up of? Yes, anything which you can see, the marker, the board, the table, the chair, the fan, anything which has mass, occupies space, which we call matter, what is it made up of? Yes, can anyone tell me what matter is made up of? Quickly let me know in the chat box. Yes. No, Bhargav Badle. This will cover the entire topic in detail from basics to advanced. So this series is B2A series. B2A series means basic to advanced series. Okay, very good, Aditri. So everything is made up of, we call atom, right? So everything is made up of atom. Matter is made up of atoms. Can you please tell me who was the first person who told us this thing, that everything around us, which we call matter, is made up of very small particles known as atom? Can anyone tell me who was the first person who told the world about the existence of atom? Atom comes from a Greek word, that is atomos, and in Greek, atomos means indivisible, which cannot be divided, right? So this atom word is derived from a Greek word, atomos. Yes, very well done, guys. So indeed, John Dalton was the first person. He was the first person who told us about the existence of atom. He was the first person who gave a theory, the atomic theory about the atoms. So John Dalton, very famous scientist. Before scientist, I will call him a teacher, because he was a teacher, a principal who moved on to Manchester, right? For the love of science, he was tutoring students individually who can dwell in the field of science. And Joule, the famous scientist Joule, was one of his, student when he was giving the, individual tuitions in Manchester, right? And he was so interested in, knowing the things around. He was so curious. He did so many things to learn about the facts, not just the atomic theory, not just he gave the atomic theory, but he gave a theory which tried to explain the reason behind color blindness. He himself was a colorblind person, John Dalton. So he tried to give a theory that can explain, right, the cause of color blindness. You can check out that theory regarding the color blindness that he gave. So John Dalton, he was the first person. Can you see this cap? So it was the thinking cap. It was his thinking cap, John Dalton's thinking cap, which was still, kept in the museum in Manchester, right? It was the thinking cap. In the later year, he used to wear this cap, right, while thinking or while working on science or the scientific phenomena. So it was his thinking cap, John Dalton's thinking cap. Yes. Okay, so guys, this was the famous quote, the line given by John Dalton, which gives the first theory about existence of atoms, right? So every particle of water is like every other particle of water. Every particle of hydrogen is like every other particle of hydrogen. Chemical analysis and synthesis go no farther than to the separation of particles from another and to the reunion. No creation, no destruction of matter is within the reach of chemical agency. So in the simple language, in the very simple language, what John Dalton said in his atomic theory, I can decode from this that everything, every element around us is made up of small particles, indivisible particles known as atoms. All the atoms of the same element are same, identical size, identical mass, but the atoms belonging to different elements, they are different, right? And whenever a chemical reaction happens, it is just the rearrangement of these atoms. Atom can never be destroyed, right? It can never be, neither be created nor be destroyed. This is all what this one single statement, this single quote from John Dalton says about the atomic theory. Yes? Sigma Physics INMO is a maths Olympiad. 2023 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 Olympiad. second stage, like after IUQM RMO, it is kind of third stage for Maths Olympiad, and NSEJS is the Science Olympiad. That is the basic difference, guys. So let us see what are the main postulates of Dalton's atomic theory that you must have studied in class 9. There is Dalton's atomic theory, the first formulated theory about atoms in your class 9th CBSE curriculum, right? So let's read. Matter is made up of small indivisible particles called atom. Everything is made up of small indivisible particle known as atoms. So the highlighting point is, according to Dalton, the atoms are indivisible. They are the smallest particles. They cannot be divided further. Yes, got it? So atoms can neither be created nor be destroyed. So you just cannot destroy an atom or create an atom. So when there is a chemical reaction happening, it is just the rearrangement of atom. The groups of atom is changing. No new atom is being created. No atom is lost in a chemical reaction, right? So, and again, atom is the smallest particle of an element that can participate in a chemical reaction. Indeed, atom is the smallest particle which can participate in a chemical reaction, right? And now the atoms of the same elements are identical in all respects, size, mass, shape, right? That means if I have nitrogen, all the atoms of nitrogen are identical in size and shape, right? And if I have hydrogen, all the hydrogen is also made up of atoms, and all the hydrogen atoms are same. But the atoms of hydrogen is different from the atom of nitrogen, right? So they are different. So atoms of different elements have different mass, shape and size. That means the atoms of different elements are different, but the atoms belonging to the same element, they are same. Yes? Next, atoms of different elements combine. So the atoms, they just combine in a fixed whole number ratio to form different compounds, right? So those compounds are known as molecule. For example, one nitrogen atom combines with 3 hydrogen atoms. So they combine in 1:3 to form a molecule known as NH3, that is ammonia. So one atom of nitrogen combined with 3 atoms of hydrogen to form one molecule of ammonia. 1:3 ratio they combine, right? So these are the postulate, the main points of Dalton's atomic theory, the very first theory which talks about atom. Yes. So there are very many Indian philosophers and scientists, my dear students, who talk about the existence of atoms. Anu, Parmanu, these are there in our ancient text. All the Indian philosophers, the great scientists, they talked about the atom existence as Anu, Parmanu, right? Yes. So Dalton atomic theory, this was the first theory given by Dalton, the first formulated theory about atom. Today also we call atoms. Yes, Maharishi Kannada, very good Aditri. So guys, in fact, John Dalton, he gave the masses of 20 elements known at that time in 18th century, right? So this was a picture taken from a museum. The symbols and the atomic number that he gave, it was the picture of the real, text that he wrote about the masses. You can see the symbols of various elements. Initially, these are the symbols that are being used. You can see the various beautiful different symbols, that were being used in the 18th century about various elements. At that time, approximately 20 elements were known. Yes. So these are the masses he gave. So much work he did in the field of science, right? Okay. It was a fantabulous theory given by Dalton, but as the science advanced, most of the points of his theory was proven to be wrong. The very first, the highlighted point about Dalton's atomic theory is that atom is indivisible. You cannot divide the atom. It is the smallest particle that can exist. But later on, we have subatomic particles which were discovered. I hope you all know atom has electron, proton, neutron. They are the subatomic particles smaller than atoms existing in the atom, right? So discovery of electron, proton and neutron inside the atom leads to the failure, you can say, of Dalton's atomic theory, in which he claimed that atom is indivisible. Everything is made up of atom and atom is the smallest particle that can exist, right? So the discovery of subatomic particles and of course the discovery of isotopes. What are isotopes? Isotopes are the atoms. What are isotopes, guys? Atoms of the same element. That means atomic number is same. Same element, but mass is different. Different mass. So Dalton said in his theory, he said that the atoms of the same element, they are same, they have same mass. But later the discovery of isotopes proved this point wrong. Chlorine has two types of atom, one with mass 35, another with mass 37. Atoms of the same element with different masses, right? That is isotope. So the discovery of isotopes, or you can say isobars. What are isobars? Isobars are the atoms of different element but having the same mass. He said if you take atoms from different elements, they are different. They will not have same mass, but isobars. These are the important terms. You also know what is isotope and what is isobars are the atoms belonging to different atoms but same mass. For example, I have argon and I have calcium. Both atoms, one is atom of argon, another is of calcium. One has atomic mass number 40, another is also having mass number 40. So two different atoms, one of argon, another of calcium. They both have same mass, right? So the discovery of isobars and isotopes later on again proved Dalton, the postulate, the points of Dalton atomic theory wrong, right? And an element can exist in various forms. You all know carbon has various allotropes. We call them allotropes, right? Diamond, graphite, fullerene, coal, charcoal, coke, they all are the forms of carbon. So the existence of allotropes, the way in which the element exists, right? That is also proved that Dalton is somewhere wrong. Yes, but we still appreciate Dalton because he was the first person who gave the formulated theory about atoms. Still we use these words atom. And the base of science, chemistry, physics that laid on that fundamental basics of atoms, that was shown by John Dalton, right? Yes. So as I talked, the discovery of subatomic particles, atom has electron, proton, neutron, their discovery is one of the major reasons for the failure of indivisibility of atom, right? So now let us see how the subatomic particles, electron, proton and neutron were discovered. So Aditya is asking me, ma'am, explain allotropes. But allotropes are the various forms in which an element can exist. Same element can exist in different forms, different arrangement, right? So they are known as allotropes. For example, carbon exists in this form. Atoms can arrange in this form, forming graphite. Graphite is carbon. Tetrahedrally, that is carbon. Diamond, fullerene. So allotropes are the various types or the forms in which an element can exist in nature, right? So this is also carbon, graphite is carbon, diamond is carbon, fullerene is carbon, coke is carbon, charcoal is carbon. So they all are carbon only, but we call them allotropes of carbon. Got it? Yes. So Dalton atomic theory were proven to be wrong by so many future experiments. Yes. So now let us study, let us know the discovery of electron, how electrons were discovered. Discovery of Electron, the fundamental particle of an atom, electron. Yes, let us know the discovery of electron. Who discovered it? How it was discovered? And everything we are going to study in this video. So there was an experiment, cathode ray experiment. Cathode ray or a discharge tube was a kind of a setup or a glass tube which was used in many science experiments, especially physics experiment. So initially, many physics experiments involve a setup including a glass tube that we call a discharge tube or a cathode ray tube, right? So many experiments were performed using that setup in physics, right? There was a like scientist Faraday's and William Crookes. Those were the scientists who were studying the conductance of electricity by gases in physics. So they are doing experiment to study how the gases conduct electricity, right? So in their experiment, William Crookes is using a glass tube. You can see the apparatus here, the arrangement here. This is a glass tube which we call cathode ray tube or a discharge tube. It has two metal strips which are acting as electrodes which can conduct electricity. You know metal are good conductor of electricity. And these electrodes are attached to a high voltage battery source. 10,000 volts this battery is giving, right? So this external battery is 10,000 volts. This battery, right? So 10,000 volt high voltage battery is there. So this was the setup which was used by William Crookes for the study of conduction of gases. Got it, guys? So this is a glass tube. There are two electrodes. Inside the tube, there is some gas which he wanted to study, right? So at very low pressure, if there is a gas at very low pressure, it can be vacuum also. Gas at very low pressure, right? So a glass tube with two electrodes. Electrodes are connected with the external battery of very high voltage, 10,000 volts. And inside this is there is a gas at very, very, very low pressure, right? So this is entire arrangement. We call it discharge tube experiment or cathode ray experiment. Got it, guys? Now, also he coated this, a zinc sulfide. A coating of zinc sulfide is there on the tube. So zinc sulfide has a special property of fluorescence. Right? What happens? So when some particle strikes the zinc sulfide, when some particle strikes the zinc sulfide, right? It has a property that if this is a zinc sulfide coating, if some particle strikes it, it will glow. So what is the use of it, ma'am? See, in chemistry, we deal with subatomic particles, small particles that we can't see with our naked eyes. So how can we, feel their presence around us? If there is some subatomic particle, how can I come to know that there is a particle? So if there is a zinc sulfide screen and if it is glowing, that means some particles are striking the zinc sulfide screen because it has that special property of fluorescence. When some particle strikes it, it will glow. Right? So what they did, they coated their screen, this tube with a zinc sulfide, right? There is a zinc sulfide coating. So that if there is some particle in the glass tube, right? So they will get to know. So William Crookes used this, right? And as soon as he switched on the voltage, as soon as he gave 10,000 volt, he observed a glow behind a positive electrode, that is anode. Anode is a positive electrode which is connected to the positive terminal of the battery. And cathode is that electrode which is connected to the negative terminal of the battery. So as soon as the high voltage is given, William Crookes observed a glow behind the anode. What is the anode? That electrode, that metal strip, which is a positive electrode, which is connected to the positive terminal from the battery. Right? Got it? Yes. So that means William Crookes thought there must be some particles which are coming towards anode and passing through the anode, that electrode, and striking behind it right? Because there is a glow behind anode at the glass tube. That means there are certainly some particles which are moving towards anode, passing the anode, penetrating the anode and striking the zinc sulfide behind it. Got it? Yes? Yo. So, he thought from where these particles must be coming from. From where these particles are coming from. So he thought there must be some negative particles. There must be some negative particles because negative particles only get attracted towards positive electrode. If some particles are coming towards a positive electrode, anode, there has to be of opposite charge. Opposite charges attract each other. Yes. So William Crookes thought there must be some particles, negatively charged particles, which are coming towards anode, penetrating the anode and striking the zinc sulfide screen behind it. Right? Then he thought from where these negative particles are coming, because he also believed everything is made up of atom and atom is the smallest particle, as said by John Dalton. Right? So he thought there is a cathode in front of. There is a cathode and cathode is a metal. So metal is made up of atoms. So this is a metal acting as a cathode, and in metals, of course, it is an element. It is made up of atoms and atom is neutral. So he thought these negative particle must be coming out of the atoms of this electrode, cathode. But how a negative particle? Atom is a neutral. It is the smallest particle that can exist. From where the hell these negative particles are coming? He got confused. Then he called one of the very famous scientists, J.J. Thomson. He handed over his observation, everything that he observed in the experiment, to J.J. Thomson for further inquiry. Yes, so he called J.J. Thomson. Dear friend, please help me out with this. There's some negative particles. I feel they are there in this discharge tube, glass tube. I don't know from where they are coming because there are just atoms inside the tube and they are supposed to be neutral. So then, beyond this point, J.J. Thomson took over this cathode ray experiment and he explored so many unknown facts about atoms and these negative particles. So these negative particles, the ray, the beam of negative particles which are going towards anode, this beam of negative particles going towards anode, because they are coming from cathode, the origin is cathode, we call them cathode rays. So what is a cathode ray? Cathode ray is a beam of negative particle, a ray in which there are negative particles. So cathode ray is a beam of negative particles. Got it? Yes? Done? Yes? So, what he logic apply? That there is a positive electrode. If particles are coming toward positive electrode, they are negatively charged particle. And from where the negative particles can come? He can see there is only another option right in front, that is cathode. So, he assumed that it is coming from cathode. Clear? So, further, all the studies about these cathode rays consisting of negative particle were carried out by famous scientist J.J. Thomson. Right? So, J.J. Thomson was the scientist who studied cathode rays or the rays consisting of this negatively charged particle in details. Right? So, what he studied? He studied the various properties of these rays, negatively charged particle. Right? So, first, these cathode rays, negatively charged particle, they travel in a straight line. Yep. And whenever they have a wheel in between their path, they push it, they apply mechanical force, the wheels start rotating. So they have mechanical effect. They can cast the shadow of an object when that object is placed in their path. They are traveling in a straight line with very high speed, right? Because these cathode rays have a negatively charged particle. Charged particles are there. so they can be deflected by electric and magnetic field. They have high penetrating power. They can go through the anode. That is why they can penetrate these cathode ray particle, right? And when they strike some metal, they produce this heating effect, right? So when these cathode rays strikes on heavy metal, so when you strike these cathode rays on heavy metal, a new rays are generated. They are known as X-rays. I hope you all have heard about X-rays. So X-rays are the rays generated when your cathode rays, they strike a heavy metal. So all these properties are about cathode rays. Now, ma'am, what are the particles present in the cathode rays? Yes, what are the particles present in the cathode rays? So the scientist Stoney named those particles. The cathode rays are the rays consisting of negatively charged particles. So Stoney was the person who named these particles, just the name, electrons. So the particles inside your cathode rays, they are electrons, a name given by Stoney. About these electrons, their behavior, everything was studied by J.J. Thomson. Right? Electron is a fundamental particle. That means electron, a negatively charged particle, is present in every atom, be it of hydrogen, nitrogen, oxygen, carbon, any atom you take, it has electron. So we call electron as a fundamental particle. Everything is made up of atom and every atom has electron. So electron is a fundamental particle which is present in all atoms. So as we know, electrons have negative charge. So what is their charge? What is their mass? Everything is studied by various scientists, right? So guys, okay. The charge by mass ratio, E by M ratio, we call it charge by mass ratio of electrons. E by M ratio, we call it specific charge also. Very important, guys, you should know E by M ratio, that is charge by mass ratio, was calculated for electrons. Charge by mass ratio of electrons, E by M ratio, also known as specific charge. This is also known as specific charge. This was calculated by J.J. Thomson by doing some experiment involving electric and magnetic field. So J.J. Thomson was the person who calculated the charge by mass ratio of electrons. So electron is a fundamental particle, and all electron, irrespective of atom in which it is present, all electrons have same charge, same mass. Electron is present in every atom with the same charge, with the same mass, and the charge by mass ratio that was calculated by J.J. Thomson is 1.76 into 10 raised to power. The unit of charge is coulomb, mass is kg. So you should know the value of charge by mass. It has a charge, the magnitude of charge divided by mass. This value comes out to be, this ratio comes out to be 1.76 into 10 raised to power 11. Got it, guys? Yes, this is the charge by mass ratio of electron. Electrons are present in cathode rays. Yo? Got it? So there was a famous physics. So this is the charge by mass ratio. Everyone should know. E is the charge on electron. The magnitude, it is the negative charge divided by the mass of electron. This ratio comes out to be this. Everyone should remember this value, the specific charge. Questions, many times questions were asked in different exams about the same. 1.76 into 10 by 11 coulomb per kg. Right? Now, Millikan oil drop experiment. Millikan did a famous experiment, that is oil drop experiment, using the oils, right, making them stationary, using the, magnetic field, external magnetic field. So this is something, some experiment which is based on the, gravitational force and also the, electric or magnetic field. So This is Millikan's oil drop experiment, by which he calculated the charge on one electron. Charge by mass value was calculated by J.J. Thomson. Millikan performed this famous oil drop experiment, right? The famous oil drop experiment, in which oil droplets become stationary by applying the external electric field, right? I hope when you study physics, electricity and magnetism, you will learn this experiment. You will get to know about this experiment, because this is based on the fundamentals of electric field, you know, and the gravitational pull, the formulas. So by doing this oil drop experiment, Millikan calculated the charge on electron. So the charge on one electron, the magnitude of charge on one electron is 1.6 into 10 to the power minus 19 coulombs. Coulomb is the unit of charge. So let me tell you, the charge on electron is minus 1.6 into 10 to the power minus 19 coulomb. This is the charge on electron, right? This is the charge on electron. The charge by mass ratio of electron, E by M ratio of electron, is also known by, was calculated by J.J. Thomson as 1.76 into 10 to the power 11 coulomb per kg. So you know E, you know this ratio, so you can easily calculate the mass of electron. So the mass of electron that you all should know is 9.1 into 10 to the power minus 31 kg. That is the mass of electron, right? So who discovered electron? Who gets the credit for the discovery of electron? Anyone? Can you please tell me who discovered electron? Dalton said atom is indivisible. There is nothing inside atom. But experiment performed by William Crookes, carried forward by J.J. Thomson, proved the existence of a negatively charged particle, that is electron, inside an atom. Right? So electron is a fundamental particle. What does that mean? That means any atom will have electron, and the electron of any atom will be same mass, same charge. Be it electron of hydrogen atom, nitrogen atom, carbon atom, all electrons are same, with same charge, with same mass. And all the properties about electrons, the cathode rays, they were studied by J.J. Thomson. So the credit goes to J.J. Thomson. Whenever the question is there, who discovered electron? The answer is J.J. Thomson. J.J. Thomson is the person who discovered electron. That atom is not indivisible, as said by Dalton. It has subatomic particles, and one of them is negatively charged particle with mass 9.1 into 10 to the power minus 31 kg, with charge minus 1.6 into 10 to the power minus 19 coulomb. That is electron. So the discovery of electron failed Dalton's atomic theory. The discovery of electron subatomic particle showed another path to the scientists, to the future of science, that there are certainly particles which are smaller than atom. They exist. And the mystery of science and the chemistry lies on those particles. Yes? Yo? So this is the beautiful word of science. Every day there are so many discoveries. Every day there are so many new things coming up which we are not aware of. Just imagine a time in 18th century, Dalton talked about the existence of atoms. Still we talk about atoms. How far-sighted he was as a person, how curious he was as a person. Right? Still we use the word atom. We call atom, everything is made up of atom. It is a fact still today. But definitely with time, more and more deeper understanding of this atom and the world of atom we get to explore. Yes? So this was today's session about discovery of electron, the discovery of first subatomic particle, that is electron. Now can you tell me, Dalton said there is atom. It is indivisible. But later, cathode ray experiment, discharge tube experiment proves the existence of negatively charged particle which is coming out of atoms. right? The atoms of electrode, they are electrons. So what does your common sense says? Atom as a whole is a neutral. And if some negatively charged particle is there, then common sense says what? There has to be a positive particle, isn't it? If there is a negative particle and atom is neutral, we know everything is a neutral. So if there is in atom, if there is a negative particle, we call it electron. So the common sense says there has to be a positive particle. But common sense is not that common, guys. Once J.J. Thomson discovered electron, he gave structure of atom. On the basis of discovery of atom, without putting much effort further, he told the world how the atom is looking alike. Like a watermelon, like a plum pudding, right? So as soon as J.J. Thomson discovered negatively charged particle inside an atom, he gave the very first atomic model, how the atoms look like. So what did he said, guys? What did he said? I hope you all know. He said atom is like a watermelon. And the seeds of watermelon are like the electrons. So that means according to J.J. Thomson, because he discovered electrons, right? Atom is a positively charged sphere. The red part of watermelon, that is a positively charged sphere, the ball. And the electrons are embedded just like the seeds of watermelon. So J.J. Thomson was the first person to give any atomic model, and he was, yay, I gave the atomic model. This is how the atoms look like. Okay, this model says it is neutral, but this is all what it said. It is neutral. Positively charged sphere is there. Electrons are there. So he said this is an atom. He didn't do much effort beyond, right? Before giving this model. Watermelon model, plum pudding model. Yes? And I am sure J.J. Thomson must be a big foodie, guys. That is why watermelon model, plum pudding model. That in today's world, if he gave this model, he will say atoms look like a choco chip cookie, right? The cookie is the positively charged, and the choco chip inside the cookie, they are negatively charged particles. So choco chip model also we can call it in today's world, right? Yes. So guys, but this model, the watermelon model, the plum pudding model, or the choco chip model, only proved that atom is neutral, nothing else. The future discovery proved that atom doesn't look like this. J.J. Thomson is a bit in a hurry when he gave this model. So, atom as a whole is a neutral. There are negatively charged particles, which was discovered as electrons, the fundamental particles. Then comes the entry of our next hero, that is Goldstein. Goldstein was the person who proved just like electrons are there, we have positive particles also inside an atom, by performing exactly the same experiment using the same setup, the same discharge tube, and calling it anode ray experiment. So anode ray experiment, canal rays experiment, that is another experiment performed by Goldstein which proved the presence of positive particle inside an atom. Yups. Yes. So guys, that's all for today. In the upcoming session, we'll be talking about the discovery of positively charged particles, the discovery of another particles inside an atom, and how the atom looks like. Everything is made up of atom, but how atom exactly looks like, this is all we are going to study in the upcoming session. So just stay tuned and keep on following this series. This series we specially launched for NSEJS 2025 aspirant in English only, so that everyone can understand irrespective of their region, right? So this is the series that will definitely help you to crack your NSEJS and learning science from basic to advanced. So this is B2A series for you all guys. In chemistry, in physics, in biology, we'll be having session for all the 3 subjects in this series. So please keep following this series if you want to crack NSEJS and become NSEJS qualifier. Right guys? So that's all for today guys. And we have already launched NSEJS Prime batch. If you are also an aspirant of NSEJS 2025, please make yourself part of this batch. Why batch, ma'am? Why not just YouTube? Because batch gives you a regularity. Batch makes you a discipline. Without discipline, you can't crack exams like this, right? Batch is something which will give you homework, where you can interact with me, ask your doubts, right? I can unmute you in the batch. You can ask me. So we are preparing for Olympiad, guys. And without asking doubts, without two-way communication, the preparation is not complete. It is very much important. If we are studying such concept, enjoying such concepts, we should have a clear understanding by interacting two ways, right? So we have already launched NSEJS Prime batch, right? The classes have started. So do not delay. If you are targeting NSEJS, be a part of a planned batch where you are getting live session, regular test based on NSEJS, mentorship, complete mentorship, and of course, all the support that we will give you in this batch. So there's a link in the description box. The batch price is 7777. You can buy this batch in 6999. Coupon code is NPR Pro. So I'll be there to teach you chemistry in the batch, guys. Yes. Done. Yo. So please register for the batch if you are interested. And if you have already appeared in NSEJS 2024, that means you are 2011 born, still eligible for NSEJS 2025. We are offering you special scholarship on the basis of the marks you scored in NSEJS 2024. Though you did not qualify, but we appreciate your efforts and we want you to qualify this year positively, guys. So if you scored 60 and above marks in NSEJS 2024, we are offering you 100% scholarship. If you got 45 and above marks in NSEJS 2024, this year you want to prepare for NSEJS, 60% scholarship, and 30 above 40% scholarship. To avail this scholarship, please fill the form given in the description box. There's a Google form to avail the scholarship based on NSEJS score. Do fill that form, right? Yes. Got it, guys? Okay. So please do like, share and subscribe our channel. And if you have any query regarding your NSEJS preparation, there is a Telegram group for my NSEJS cult. Let's explore science together, right? So there's the link in the description box, Telegram group link for Vedantu's NSEJS 2025 updates. Please do join that Telegram group and interact with the people like you, the persons who are targeting the same exam, who share the same love for science. Yes. Done, guys? Okay, guys. So, and if you are IOQM or RMO qualifier or any credential, academic credential that you have, and you want to avail scholarship in NSEJS Prime batch on the basis of same, you can contact me. You can mail your details with credential, certificate, scorecard on this email ID, right? So this is my email ID. You can contact me, and the next session will be having very soon. Will share the complete schedule of this series on the community post. So just follow this series for physics, chemistry and biology so that it can help you to crack NSEJS 2025. Right, guys? Especially for NSEJS aspirants in English. Got it? Okay, guys. And this is my Telegram ID. If you have any doubt regarding, this is my Telegram ID, guys. If you have any doubt regarding NSEJS Prime batch or NSEJS preparation, you are most welcome, guys. You can ask me in the comment section of the video or on my Telegram ID. Yes. NSEJS form, the registration for NSEJS will begin at the end of like July, or you can say in the August. In August, the registration will be open. It will be online registration. You can, enroll yourself, register yourself for the exam on your own, right? So the registration for NSEJS Junior Science Olympiad for 2025 will begin in August, right? Yes, guys. Any doubt if you have, you are most welcome, guys. And I have been guiding the students, mentoring the students to crack the Junior Science Olympiad from the past many years. So I hope I can help you out also in this journey, guide you as per my experience, as per my knowledge. Yes, I would love to help you out, guys. So here you can contact me. So till then, bye, take care, God bless you. पढ़ते रहो, बढ़ते रहो, मचाते रहो, देश को गोल्ड जिताते रहो. Keep learning, keep growing, guys. Bye, take care, God bless you.